On this 2011 through 2025 F250 with the 6.7 power stroke, P2200 is best treated as a structured NOx control system electrical diagnosis. In plain language, the truck may be seeing a problem with the NOx 11 sensor circuit, the NOx module, or the wiring that lets that module power up and communicate. The truck may run normally, or it may set emissions warnings and change how the emission system operates. Keep the scope broad at first. Possible contamination, connector issues, power and ground problems, module circuit faults, or exhaust, intake, crankcase ventilation, modification, or interference-related concerns can all point the test path in different directions. Start with the basic system checks, then pull the codes. If other NOx, SCR, oxygen sensor, reductant, or communication codes are present, do not treat P2200 in isolation. Check what those codes mean first, and follow the branch for the code group that is actually setting. Save any captured operating data before clearing codes, because clearing PCM codes erases that information. Also, if regeneration starts while you are testing, let it finish before continuing, because it can bias the values you are watching. On the P2200 path, the first branch moves toward contamination checks. Other branches in this same shared routine may have you record captured conditions, check recent SCR catalyst history, compare cold soak temperature sensors, check for unrelated codes, or check reductant concentration before coming back into the NOx path. Those early branches use a few hard gates. For the recent SCR catalyst or low mileage branch, the mileage point is 8,047 kilometers, 5,000 miles, and the stop-and-go drive is run until coolant temperature is above 70 degrees Celsius, 158 degrees Fahrenheit. For the cold soak temperature comparison branch, the exhaust system has to stabilize for a minimum of 6 hours. Then AAT, EGT12, EGT14, and IAT are compared and should be within 30 degrees Celsius, 54 degrees Fahrenheit of ambient temperature. For the reductant concentration branch, DEF-CON is checked for between 28 to 35%. If that branch requires a steady-state post-service drive, the distance is greater than 16 kilometers, 10 miles. If none of those branches apply to the P2200 job in front of you, continue with the P2200 contamination and electrical path. Next, look for anything that could contaminate the NOx sensors. That includes unapproved silicone sealers, excessive oil consumption, coolant or oil leaking internally in the engine, or unapproved cleaning agents. If you find a contamination concern on the P2200 path, repair the source of that contamination, change the engine oil and filter, then clear the codes and repeat the self-test. If there is no contamination concern, keep moving down the path. Now do a careful visual inspection. Look over the NOx modules and sensors, the exhaust system, any aftermarket accessories or performance modifications, the intake air system, air filter, charge air cooler system, intake manifold sealing area, oil fill cap and oil level indicator area, EGR valve gasket area, crankcase ventilation system, and anything that could create radio frequency or electromagnetic interference. If you find a concern, repair it as needed, clear the PCM codes, and repeat the self-test. If the visual inspection is clean, P2200 moves into the NOx module electrical checks. From here, only test the suspect NOx module indicated by the code. For P2200, that is the NOx 11 side. With the ignition off, disconnect the applicable NOx 11 module connector, turn the ignition on, and check voltage at C4891A pin 1. Make sure the meter lead locations are positively identified before you test. If they are not, pause and avoid guessing. If voltage is greater than 10.5 volts, continue to the circuit open checks. If it is not greater than 10.5 volts, repair the open circuit, clear the PCM codes, and repeat the self-test. With the ignition off, disconnect the PCM-B connector. On the P2200 path, check resistance from NOx 11 connector C4891A pin 2 to PCM connector C1232B pin 14, and from C4891A pin 3 to C1232B pin 15. If both resistances are less than 5 ohms, continue to the power and ground resistance check. If either one is not less than 5 ohms, repair the open circuit, clear the PCM codes, and repeat the self-test. Next, check the VPWR and ground circuits for excessive resistance. With the ignition off, disconnect the BJBC connector and measure the suspect NLX module power and ground circuits. Again, make sure the exact meter lead locations are positively identified before you put the meter on the circuit. If the resistances are less than 5 ohms on the P2200 path, the next directed action is to install a new NOx11 sensor, reset the nitrogen oxide sensor, and move to the drive cycle. If the resistance is not less than 5 ohms, repair the excessive circuit resistance, clear the PCM codes, and repeat the self-test. Do not replace the NOx module unless this diagnostic path directs you to do it. After the NOx11 sensor has been installed and the nitrogen oxide sensor reset has been performed, carry out the drive cycle. If no codes return, the system is operating correctly at this time. If P2200 is still present after the drive cycle, move into the NOx module operation check. If the shared NOx routine sends you into a calibration branch instead of the P2200 only path, reconnect the PCMB connector and program the affected NOx module to the latest calibration. If the calibration-related concern remains, the routine directs a new NOx module, nitrogen oxide sensor reset, code clear, and self-test. If it does not return, treat it like a connector-related concern that was corrected by the connection and programming work. For the P2200 module operation check, work with the NOx11 module. Disconnect the applicable NOx module connector, inspect for pushed-out pins and corrosion, then reconnect the connectors and make sure they seat correctly. If the concern is no longer present, the system is operating correctly at this time, and the fault may have been caused by a loose or corroded connector. If the concern is still present, install a new NOx module in question, reset the nitrogen oxide sensor, clear the GDM and PCM codes, and repeat the self-test. If the job branches away from a P2200 only electrical fault and into NOx or SCR performance testing, keep that separate from the P2200 electrical checks. One branch runs DPF manual regeneration, DPF parameter reset, SCR learning initialization, and a drive cycle before deciding the next step. Another cold comparison branch stabilizes the exhaust for a minimum of 6 hours and compares AAT, CACT, ECT1, and EGT12. Those values should be within 10 degrees Celsius, 18 degrees Fahrenheit of the ambient temperature. If any EGT sensor connector was disconnected with ignition on and engine off, turn the ignition off for 30 seconds before attempting to start the vehicle, and do not crank or start until the ignition has been off for at least that time. On the performance side of the shared routine, pressure sensors are checked against baro. EBP needs to be within 7.5 kilopars, 1.09 psi, and MAP needs to be within 4.5 kilopars, 0.65 psi. For the fuel rail pressure check, leave the ignition off for a minimum of 15 seconds, so rail pressure can bleed off. Then FRPA should read between 0 kilopars, 0 psi, and 3,447 kilopars, 500 psi. The MAF check is run with coolant temperature greater than 70 Celsius, 158 degrees Fahrenheit, and MAF HC should be between 30 to 36.8 Gs per second at idle at 1200 RPM, and between 116 to 125 Gs per second at 2000 RPM. The EGR response check expects the valve position to follow the commanded EGR PID within 0.2 seconds. If the branch moves into reductant dosing, first make sure there are no low diesel exhaust fluid warnings and fill the reductant tank as needed. The dosing measurement uses the injector test setup, watches line pressure and backup pump duty cycle, and records the amount dispensed. The backup pump duty cycle may cycle above 50%. A good dispensed volume is 40 to 50 milliliters, 1.35 to 1.69 ounce. If volume is not in range, the branch decision uses line pressure. Greater than 70 psi, 483 kPa, and less than 75 psi, 517 kPa points one way, and other pressure results point another way. Watch for external leaks and verify the injector spray pattern is uniform. After that, the visual leak test branch again checks DEF level warnings, sets up the injector test fixture, and if a leak concern is present, it directs the reductant injector path. Some outcomes call for a steady-state drive greater than 16 kilometers, 10 miles. The next shared branch looks at SCR ammonia. If that PID is greater than 0.14 ounces or 4 grams, initialize SCR learning, reset the DPF parameter, reset the oxidation catalyst function, and continue. Then the routine checks EGR effect with the EGR unblocked and blocked. Run the test with ECT greater than 80 degrees Celsius, 176 degrees Fahrenheit. Command 1500 RPM. Command VGT CMD duty cycle to 80%. Reduce EGR command to 0%. Wait 30 seconds, and record the unblocked NOx 11 value. Then block EGR flow using a 2-inch, 5-centimeter flexible putty knife, taking care not to damage the seal or sealing surface, and repeat the measurement. The difference between the NOx 11 values should be less than 60 ppm to continue. Remove the putty knife and reconnect the EGR tube when that step is complete. Output control testing can set extra codes, so clear all PCM and TCM codes after diagnostics are finished, and repeat the self-test. The NOx 11 response check warms the system and compares NOx 11 under idle and commanded conditions. If the NOx 11 PID is already greater than 100 ppm during the initial part of the check, wait 3 to 5 minutes before continuing. Warm the engine until ECT is greater than 80 degrees Celsius, 176 degrees Fahrenheit, and EGT12 is greater than 200 degrees Celsius, 392 Fahrenheit, for 2 minutes. Then allow the engine to idle for 2 minutes and record NOx 11. Next, command VGT CMD duty cycle to 80%. Decrease EGR command to 0%. Command FRP DSD between 450 to 550 bar, 6500 to 8000 psi, or 45,000 to 55,000 kPa. Wait 1 minute and record NOx 11 again. The difference between those NOx 11 values should be greater than 100 ppm. During cooldown, NOx sensors may read 0, so do not replace NOx sensors unless the branch specifically tells you to. If the shared routine moves on to downstream NOx comparison, verify AAT is greater than 4 degrees Celsius, 40 degrees Fahrenheit. Then warm the engine until ECT is greater than 80 degrees Celsius, 176 Fahrenheit, and EGT12 is greater than 230 degrees Celsius, 450 Fahrenheit, for 2 minutes. Let the engine idle until EGT12 is less than 125 degrees Celsius, 257 Fahrenheit. Then compare the NOx sensors. NOx 12 and NOx 13 should be within 5 ppm greater than or within 40 ppm less than the NOx 11 value. For catalyst conversion verification, verify AAT is greater than 0 degrees Celsius, 32 Fahrenheit. Drive with steady pedal between 89 to 97 kilometers per hour, 55 to 60 miles per hour, and hold exhaust gas temperature between 200 to 300 degrees Celsius, 392 to 572 Fahrenheit. The actual NOx catalyst conversion efficiency must be at least the minimum value for reduction concentration quality plus 3%. That minimum value may change with exhaust temperature and exhaust flow rate. Near the end of the shared routine, if an additional code is present, stop chasing the current result and diagnose the next active code path instead. If no other code is driving the concern on that branch, the routine directs the NOx module 11 path. If the testing reaches the PCM operation check, disconnect the PCM connectors, inspect for pushed-out pins and corrosion, reconnect everything, and make sure the connectors seat correctly. If the concern is gone, treat it as a connector issue. If it is still present at that point, the routine directs PCM replacement, then code clearing and a repeat self-test. Keep verifications separate from testing. On a P2200 job, do not jump straight to a sensor or module. Check for contamination, inspect the system, prove module power, prove the NOx 11 circuits, and only replace parts when the directed path tells you to. After the repair, clear the proper codes, repeat the self-test, and confirm P2200 stays gone. For more diagnostic training, visit stepdiagnostics.com.